الحضور الكريم، نستضيف الآن على المنصة المهندس هوا جيانغ تاي، نائب رئيس جمعية مهندسي الإطفاء في ماليزيا. هوا جيانغ مهندس إطفاء مؤهل وذو خبرة طويلة، تخرج من جامعة هيرويتوات، كما تخرج من جامعة أدنبرا في اسكتلند بدرجة الماجستير في هندسة السلامة من الحريق. يتمتع بخبرة تزيد عن 30 عاما في هندسة الإطفاء وهندسة السلامة من الحريق. شغل المهندس هوا جيانغ منصب الرئيس الدولي وعضو مجلس الأمناء وعضو مجلس الإدارة لجمعية مهندسي الإطفاء، ويشغل حاليا منصب نائب رئيس جمعية مهندسي الإطفاء في ماليزيا، كما أنه عضو دائم في لجنة معهد البحوث والمعايير الماليزية ولجنة معايير السلامة والوقاية من الحريق، كما يترأس اللجنة الفنية الخاصة بخصائص الحريق لمواد البناء، ومسؤول عن إعداد مجموعة من المعايير الخاصة بمنهجية مختبرات الفحص والاعتماد. كما يترأس مجموعة عمل تقنية لتطوير المعايير الماليزية الخاصة بطفايات الحريق، وعضو في اللجنة الفنية الخاصة بأنظمة مواد الإطفاء النظيفة، وشارك في تأليف الدليل الإرشادي، وهو دليل خاص بقوانين البناء الموحدة في ماليزيا. يحدثنا المهندس هوا جيانغ عن الحلول المستقبلية لما بعد كارثة برج غرينفيل، فليتفضل إلى المنصة مشكورا. Mr. Hua, please make your way to the stage.
Good morning, ladies and gentlemen. And that's better. Now, first of all, I will thank the organizer for inviting, for the kind invitation for me to be here to share my knowledge and experience. There's been quite a number of fire incidents that is happening lately, starting from 2017 Grenfell Tower with a lot of fatalities. And subsequently, the latest, of course, is a heritage building up in flame, Notre Dame in Paris, which is an iconic building around the world. I believe most of you have been there. And well, it's a shame, even though it's going to be rebuilt with hundreds of millions of donations, it can never be the same again. I believe you do have heritage building here. The title of this morning's paper, The Way Forward Post Grenfell Tower, actually is going to look at what actually went wrong, whereby we have so many high-rise buildings building fires in the past couple of years, all related to either cladding or other incidents. I believe Dame Judith Hackett came up with her findings, and actually we can then narrow it down to focus on a few keywords. One is deregulation. When the country goes develop into a developing country, it actually deregulates a lot of responsibilities and authorities from the government agencies down to professionals. But then, if you do not have a check and balance monitoring system, a lot of things are going to go wrong, because everybody else is a fire expert. It can never be. Who is actually checking all these fire experts? Somebody need to do that. So that is one keyword, deregulation. And for those countries who are developing, actually they are at the right frame of time to actually start looking at it seriously. Secondly, we are looking at competency. Competency actually tells a lot about a person's character, a person's profession. Engineers, architects, fire risk assessors, are they competent enough? That is another question that is being raised. So, normally for all my papers, I would like to look at fire incidents and the lessons learned, because if you do not look at what happened, you cannot prevent it. Grenfell Tower, a picture tells 1,000 words. If you look at this particular photo, you realize that the fire rescue department is trying their very best, but if you look at the number of water and the level they reach, it's only about 30 meters, 10-story. If we build any higher than that, the firefighting has now, in the modern world, been shifted from external firefighting into internal firefighting. Now, if you look at the shift in the fire safety strategy, then you realize why fire protection system is now so important internally. Not only you build them, put them in, but you also have to maintain them. A lot of people look at this photo, but what do you get out of it? First of all, if you look at the amount of smoke particles that is generated, if you look at it, it's whitish. It's coming out of synthetic materials that is highly toxic. 50% of the residents or the occupants of the Grenfell Tower is believed to be killed by the toxicity of the smoke rather than burned to death. Again, if you look at the fire gradients, the color of the fire, you notice that there are 4 different types of color: red, orange, yellow, and white, of which white is actually the highest, approaching probably about 1,000 degrees C. Look at this picture again, you understand why. Everything else internally was actually burned except steel, even though this building has just been refurbished with double glazing system. Cladding fire, why is it so ferocious? It's because of highly combustible polyethylene. If you look at the time frame, you can see the fire spreads very, very fast. Within 20 minutes, it goes up 10 floors. It never happened before. This is a local iconic building again, the address, and I've actually mentioned it many times with the professional engineers and architects. When you design a building, you must also take into consideration the wind shear factor externally. This fire actually was traveling up the external surface of the building so fast it's because of the gulf wind coming in, hitting at the building, and it had nowhere to go but except upwards. With the wind pushing the fire, you have plenty supply of oxygen, and hence the ferocity and the speed of fire propagation. This happened in Dhaka not too long ago, about a month and a half. A chemical storage was actually located on the ground floor of this series of buildings with garment factory, with offices and all that. Now, if you put hazard, high risk, what they call occupancy so close to the rest of the residents, this is the end result, all right? So if you can separate the fire risk from the rest of your fuel load, perhaps incident like that would not have happened. Now, if you look again, chemical plants, this blast in Tianjin, you look at the crater, you look at the building there, it's more than a bomb. And this particular incident tells us something else. Not all fires you can use water, because chemicals, a lot of them are water reactive, all right? 100 over firefighters died in this particular incident. Now we have another issue to look at because of global warming. There are more incidences created by natural disasters that actually have a lot of impact on fire safety strategy. All right? If there are flood, mudslide, firefighters might not be able to get to the building on fire. So what about a seismic reaction? Building collapse, roads are blocked, bridges collapse. Cyclones, typhoons, never heard before at this kind of frequency every year. They have just run out of names. Last time they used to have a lady's name to name a typhoon or a cyclone. They have run out of names. Now they have to use a male name. What about global warming? Your ambient temperature has gone up so high, you now have forest fire across the globe in continents never heard of before. The latest one is in Finland. So you can imagine that, climatical change also is going to have a lot of impact because of ambient temperature rise. Current challenges in construction industry. Our building code is prescriptive based. We need to start reviewing them to turn it into performance based. Construction industry always go for dollars and cents, financial gain, driving down the life safety aspect. So are we sacrificing technical value for commercial gain? This is another area we got to look at and start thinking about it. There are not sufficient understanding of fire and smoke behavior for professionals who are designing buildings. Now, if you do not understand your enemy or know your enemy well, like General Sun Tzu says, know thy enemy, you win the war without sending a soldier. So understand fire propagation, understand smoke behavior, the building will be designed safer. What about building regulations, code and standards? They are too slow to be reviewed. Most of them are outdated. They can't even match the modern construction era. Mega-sized shopping complexes, airports, sports stadiums, high-rise and super high-rise complexes. If you look at the maximum travel distance, they go beyond the prescriptive code. So there are a lot of issues that we have to be contended with. And let's look at the challenges. That is facing the construction industry. Lack of a centralized building plan, approval process, and structure. America, Australia, they have individual state approving authority. There's never a standardized approving process. If you have a federal system, it will be very much easier. Lack of coordinated meetings between building stakeholders. When did the building owner have meetings during preliminary design stage together with the architect, fire and rescue service, insurance people, and a fire engineer? No, everybody is actually having their own ideology in how to build this building. And eventually you have all the problems accumulated, and it takes a longer time to build, a lot of cost to rectify the issues. Essential role of fire engineers, fire safety engineers, and fire safety managers, including technicians, must now be emphasized and recognized. Because if you want to design a building safely, fire safety concept will have to be decided during prelim stage. And the fire engineer working with the architect and the owner with the fire and rescue service will actually pave the way for a very smooth design and implementation of the entire project, save a lot of money and time. Many laboratory testing methodology is outdated because the process of standard development takes ages, sometimes more than 10. Now, if you look at that, and some of these are not fit for purpose, they are testing just for the sake of testing. But when you look at the system that is being implemented into the industry, the application is totally different. If you look at the Grenfell Tower, that's one of the examples, but there are so many other examples in the market. What about after testing? The product, that is a prototype. Normally, the manufacturer will spend probably a whole month to actually manufacture that prototype to go for the test. After passing the test, every single day, they might be producing 500 sets or 600 sets. Other quality is exactly the same. 5 years down the road, the upstream supplier change. Now, is the other product again the same? So there are a lot of issues that we have to really look at carefully. Deregulation, I've talked about, with no check and balance system. Test report with no life limit. I can still see test reports 20 years old, and they're still being used to actually seek approval. But then there are many assessment reports being generated by laboratories without even testing. These are actually a very dangerous trend. Products actually should be reviewed every 5 to 10 years. If there's any changes in the upstream material, by right, it should be retested. Little emphasis on the CPD program for fire professionals and all stakeholders. CPD actually stands for Continuing Professional Development. An engineer that graduated from a university and just keep practicing for the next 20 years, you can imagine what's going to happen. He never upgrade his knowledge, his experience. The world outside changed so many years, but his knowledge and experience stays at university level. So CPD program like today is actually very important. I'm very glad to see so many of you take time off to come and attend this forum. Lack of ERP, ERM, ERT, and ME program. ERP, emergency response planning, for building owners is very important because you have to handle a crisis. ERM, emergency response management, ERT, emergency response team, and mass evacuation program. All the building owners are supposed to get this ready and drill them, fine-tune them until they are effective. Commercial pressure-driven down the quality of fire safety products. What about fire and smoke behavior? How much do we know the danger of fire? It generates heat, smoke, toxic fumes, carbon dioxide, water vapor, and the last one you have to pay attention because it also has a lot of carcinogen byproducts. I always joke that, if you die in a fire, good luck. If not, you might contract cancer for the next 20 years. In fact, if you look at the latest finding from U.S. Fire and Rescue Service, it's actually shocking because the fire statistic, fatality of firefighters in fire statistic actually goes down. But the health statistic actually goes up. Now, what wasn't realized at the beginning is that the firefighters thought they are well protected. They have PPE, they have SCBA, and when they go into the fire, they breathe clean air. But what they did not realize is that all the toxic particles rested on their helmets, on their suits. So when they go into a changing room, when they change, the toxic particles are all airborne. And then when they remove their SCBA, it goes into their lung, and most of them contracted actually lung cancer. So there is another process that we need to look at. What are the changes in the fire? We now have higher fuel load with a lot of synthetic materials on the market, higher smoke index and toxicity, higher heat flux generated, and all these significantly change in the modern fire behavior. What is the impact? It increases pyrolysis and shortens flashover, lower visibility, longer evacuation time, and longer fire extinguishment. So you see everything changed, but if you look at the fire protection system design, they still are the same. This is a research carried out in BRE. It's nothing to do with what I'm going to talk about, but the impact is still the same. They're testing actually high-rack storage. And you see the amount of the smoke generated. Now tell me, can you still see the exit sign? No. Can you see the escape route? No. Then tell me, please, ladies and gentlemen, why are we still mandatory saying that we must put the exit sign on top of the fire door? It's time that we review, all right? And so Norway came up with this innovative design, putting the exit sign on the carpet, illuminated. You don't even have to look for exit sign anymore. Because during a fire, imagine if this corridor is filled up with smoke, you are asked to crawl on the floor. You just follow the arrow. In shopping complexes in other countries, this is in China, underground, they have it luminous signs on the floor, whereby you don't even have to go and look at where you're going to go. Just follow the sign, you get out. A lot of the airports now, modern airports, they also have it on the floor. But be careful, because there are also a lot of arrows having sales. Don't follow those arrows. You might end up in a Levi's store. What about fire hazards and fire risks? We have to actually reduce the fire hazard to reduce the fire risk if you want the statistics to come down and the fatality. Modern synthetic materials generates high heat flux, moderate smoke intensity, but ever presence of toxicity. Increased pyrolysis, shortens flashover, and a lot of now low-cost interior decoration and furnishing, high and good aesthetic value, but mostly highly combustible. So interior designer is another area they have to be regulated, which are not at the moment. So fire risks also increase with time. Look at when you buy a new building, first year, there's nothing much. 5 years, 10 years down the road, go and take a look at that building again. It's full of a lot of combustibles. So if you separate the fuel loads from the ignition source or potential ignition source, like what is happening in Dhaka, then perhaps the fire risk will come down. We need building regulations, definitely, because without building regulations, it's a free-for-all on the market. Now, you also need a Fire Services Act, because building regulation only goes up to the point where the building is new and completed. The moment it's handed over to the building owner, it's another area altogether, and nobody is monitoring unless you have a Fire Services Act. They make sure that the owner, it's the owner's responsibility to upkeep the fire safety of the building and the occupants. And of course, there are regulation and penalty clause for that. Now in Malaysia, we also produce a guide to fire protection in Malaysia because it's very difficult for normal people to read bylaws and understand. So we produce a guide with a lot of data inside, extracted, summarized from regulations, from codes and standards with easy reference, 3D diagrams. Codes and standards are actually complementary documents to regulations, which is also very, very important. We have now adopted BS 9999, which you convert to MS 1183. This standard is about 1 inch thick, but they have a lot of good design guidance inside. But don't forget, these are all dynamic documentations. It's a dynamic process whereby you need to actually review them probably every 5 to 10 years to keep them up to date. So, if you were to be stuck with a prescriptive code, it's dangerous because it's deemed to satisfy. That means if you design like that, it is said to comply and satisfy certain fire safety rating or things like that. But then, you've got to make sure that that standard or that building regulation got to be upgraded. Because if you were to look at the building regulation that we had, it was enacted in 1984, but we actually borrowed it from British regulation at that point of time. And if we look back, at that point of time, the regulation is merely established for low-rise buildings. And at that point of time, also the township are not that well developed. So if you look at that, again, the modern environment is totally different. Townships are very congested. And it created a lot of problems for the fire and rescue service. It cannot cater for modern high-rise or super high-rise or mega shopping complex. That's why now we have to go for performance-based design. But again, performance-based design also have its drawbacks because each of these engineers actually are assuming the fire size according to their experience. So until and unless we develop a data bank for fixed fire size of building materials, it'd be quite difficult to actually assess whether the design is 100% safe or not. Of course, certain universities has carried on beyond that in carrying out full-scale investigation, like University of Edinburgh. Need to review and update building regulations, need to categorize build occupancy risks because you have different category of occupancy risks. Hotels, office, shopping complex, airport, sports stadiums are all different. Now, public assembling areas, also the category is different. Then you've got to look at the occupancy with sleeping risks. Do you have people sleeping inside? Because when you sleep, your senses are lower. An alarm bell may not be able to wake you up at night, especially if you take tranquilizer, medication, or things like that. You also need to classify building where people are unfamiliar with the building. What about people with disabilities? Have we actually take much thought into that? Need to consider extended protected corridor where maximum travel distance is exceeded in huge shopping complexes. So when people get into that, at least they're protected until they egress from the building. Introduce mass evacuation with lift assist and refuge floors. In China now, it's mandatory for high-rise and super high-rise. You can't just get people, occupants, to walk down 60 floors, 80 floors, 100 floors. That's impossible. Tell me frankly, how many of you can walk down from 60 floors? Put out your hand. You can go for lunch if you can. I can. I hike mountains every weekend, okay? Because I also know that it's no joke coming down staircases during a fire because that is the only way you get down. That is the only way. Unless they have a lift evacuation program, you can't. You've got to depend on your 2 feet, okay? Adopt phased evacuation. Now we are looking at why do we have to get everybody out of the building for a high-rise building like Burj Khalifa? No. If you implement all these programs, if you can identify the source of the fire, you can actually compartment and only evacuate those people that is above the floor on fire. The rest of them, life as usual. But this will have to be properly thought out with the program and management team to make sure that it works, right? Adopt phase, performance-based design should be introduced with life safety goal, taking human behavior into consideration. I've just conducted a training course for professional engineers in my country. I tell them, don't be so confident that when you design a fire detection alarm system, when a bell rings, everybody goes. Worst statistic indicated that 85% of the people ignore fire alarm signal. Okay? So this is human behavior. So if you want to get people out, there are other things that you do. National codes and standards is actually essential. You look at adoption of international, regional, or trade standards in that sequence. Codes and standards are dynamic and should be reviewed every 5 years. Should also be fit for purpose, not just for testing certain equipment for the test. It should be a complete series as well. You must have testing methodology, specification, system concept, fire safety design, installation, testing, maintenance, code of practice. So it must come in a series and not just testing methodology. So for preliminary design, architects, fire engineers, building owners, fire safety division of AHU, authority having jurisdiction, including insurance underwriters, should be involved in the discussion and the meeting to establish a holistic approach of fire safety strategy for the building. And once the fire safety concept foundation is set, then the rest will be very easy for the CNS, M&E to come in to actually complete the design. Building plan approval is also very, very important. If you have that, then you root out a lot of issues and problems. And passive fire safety design by architects, CNS, active fire protection by M&E engineers will complete the entire design between active and passive. If you want to find out the systems, more information about the system, log into that website, okay, using a mobile. You find that there are complete information on systems available. Plans should be approved for regulation compliance, but detailed design should be code and standard compliance. New project pre-consultation should also reduce approval time. That means the owner should actually have a consultation or meeting with the civil defense or the fire rescue department to root out or talk about their problem. Laboratory testing need to acquire latest laboratory testing equipment, needs to be accredited by recognized body, needs to be calibrated and certified, needs qualified and trained technicians, and it also should include performance-based tests, like fire doors and ironmongeries must subject to actually cyclic endurance tests. I have no time in today's paper. I have a full paper on that, of how do you do that and why you should do that. Product systems listed, tested also need to be listed by quality assurance agencies. It's no point you test a product, but the quality is not being controlled, like CE marking is one of the systems. Ad hoc open market sampling conducted by monitoring is also very important. In Malaysia, we take the doors that's tested with licenses, bring it back to the lab and test again. And many a times, these doors that is produced after the test normally fail the test. Some of them is quite bad, all right? So then the license, the manufacturer will be calling to explain why the license should not be cancelled. So sample versus full-scale testing is also very important. That's why cladding now, they don't go for what they call surface spread of flame. They go for full-scale testing. This is the surface spread of flame test, BS 476. If you look at it, there's no fire at all. It's only a radiant panel. And if you mount the sample there and you measure, it's actually combustible, unless you have an aluminum facing. But if you look at it, EN now is not placing the sample at 90 degrees, but directly, all right? So still, it's only a sample test. This is a full-scale test, which is more realistic. And if you look at BRE's test, 7 tests after Grenfell, if you look at the Australian test, all claddings fail their test. Two corner room tests. This is another test that actually is now a requirement by EN. Instead of testing what we call fire-rated partition in a normal furnace, 4x4 furnace, now they go for corner tests. What about fire professionals? Fire professionals will need to be regulated as well. If you can set up a board of architects, board of engineers to regulate and register all the professional engineers that is practicing, that itself will then make sure that whoever that is registered will have to be responsible for what they are doing, all right? Nobody can have the authority without carrying the responsibility at the same time. So registering our fire professionals are actually essential and is necessary if you want to root out some of the problems we are facing now. Other than professionals, designers, you also got to look at listed installers, because installation by the contractors is very important. A system can be well designed, but if it's wrongly installed, it doesn't work during a fire. So there are a lot of things, you look at a multiple level of actually competency in terms of all these so-called stakeholders. And in Malaysia, all the buildings must apply for a fire certificate after the building owner takes over, so that, okay. Few more slides, I'll just finish it. Fire risk assessment is very important because buildings after they are occupied, if you do not conduct regular fire risk assessment, you will not know what are the new risks that is being presented, all right? So fire risk assessment should be carried out, not just by the insurance underwriters, but also by the building owners with qualified and registered fire risk assessor. Fire Safety Development Program, introduce CPD program to all fire professionals, and normally they must accumulate certain hours every year. Thank you.